Okay, in this section we're going to work on our approximating skills. So the I can statement for this section is I can approximate. We're going to write square roots here, so square roots and cube roots. So we're going to be approximating square roots and cube roots. So the warm-up is find the following square roots without a calculator. Again, these you've got to have these memorized. So the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and you'll notice that I've put these in a nice convenient order just to kind of help. But you do definitely have to have these memorized. Please make sure you do. Okay, and then what does it mean to approximate something? Well, when we approximate something, that means that we get close to the answer. Sometimes we use the word estimate. Okay, we're not interested in getting an exact answer. We just want to get close. We just kind of want to get in the ballpark, sometimes we say. And this one says, can you approximate the center of the line? So most people are pretty good at eyeballing, we'll call it, eyeballing the center of the line. So I'm going to say the center of that line is about right there. I'm going to put a mark right there. Now, it may be a little bit off, but again, it says approximate, so all we have to do is just estimate there. And then the next part says, give an example of a number that is between 6 and 7. Now, if somebody says, give me a number between 6 and 7, most people will give a decimal and they'll say this. They'll say 6.5. If we want to narrow in a little bit more and say, hey, can you give me one that's between 6 and 7 but a little bit closer to 7, maybe something like 6.8 or 6.9 or something like that, and one that's closer to 6, probably something like 6.1. Those would be perfectly good answers. Again, there's no perfect answer for any one of these, but this one is definitely between the two of those. This one's closer to 7 than it is to 6, and this one's closer to 6 than it is to 7. So let's talk about approximations. Approximations are very, very useful things, especially in the real world. We use approximations in the real world all the time. If we're at the grocery store, we just kind of estimate how much we've spent, or we kind of have a ballpark idea of what our grade's going to be, or different things like that. But there are times when the exact answer, so go ahead and write the word exact right here, when the exact answer cannot be found, or it takes too much time and effort to find that exact answer. So in these cases, we rely on approximations, we rely on close answers, or we're going to write the word estimate here. We're going to kind of use those words interchangeably. So approximations or estimates that can often be found very quickly, or we're going to write down through brute force, let me get this down here, through brute force. And that just means we're just going to plow our way through. We're just going to make it so our answer is really close. And sometimes that can be effective. Now, you're not going to run into any problems that don't have an exact answer for a very, very long time, if ever. If you take some advanced math classes, you may run into something like that. But it does happen a lot of times in the real world, especially in various work fields. Okay, now, if you do run into something like that, you're not always going to have the time or the inclination to pull out a calculator. So go ahead and write calculator right here. They're great tools. Okay. Pull out a calculator to get kind of that exact answer or something like that, when just a reasonable estimate would be good enough. So it's a good thing to understand how approximations work and how to make relatively accurate approximations. Now, this is really important. I've bolded this and put some asterisks on these. So we will not use the square root button on our calculator except to confirm, which means to kind of check our answers. Okay, and this section is about the process. I want you to underline the word process. It's about the process of getting a good estimate, not the answer itself. Okay, so our answers are just going to be close, and you may have a different answer than your neighbor. It's the process that we're after. It's the thinking skills as we go through and do this that are really important here. So we're going to break down a problem on example number 1, and we're going to run through and do this, and we're going to talk about how you can come up with a decent estimate for this. Now, this is a really ugly number, the square root of 55. Okay, and what we want to do is we want to round to the nearest tenth, we're going to change the instructions just slightly on the assignment, because we just want to be within a tenth. So if we were going to round this to the nearest tenth, here's what we'd want to do. We'd want to know what the hundredths digit is so that we can round to the tenths place correctly. So we're going to just kind of come close to that, and we'll fudge a little bit. We just want to get within a tenth of the answer. So let's run through this process and see how this works. So it says name two perfect squares that are very close to 55. Now think about that list of perfect squares, and if I need to slide back up here and we take a look at this right here, 55 would be between 49 and 64. So I'm going to put 49 right here, and I'm going to put 64 right there. Those are two perfect squares. Those are numbers that we know the square root of really quickly. So what this means is the square root of 55 has got to be somewhere between the square root of 49 and the square root of 64. Okay, so if I were to put a little square root of 55 right here, it's got to be somewhere in between the two of those, because 49 and then 55 and then 64. So if I take the square root of all three of those, square root of 55 has got to be somewhere in between there. So in whole numbers, that means the answer's got to be between the square root of 49 and the square root of 64. So the square root of 49 is 7, and the square root of 64 is 8. So it's got to be somewhere in between there. Now this is kind of like the problem that we had in the warm-up, where it says, well, let's just pick a number between the two of those. So if we want a number between 7 and 8, let's try 7.5. Okay, so here's what we're going to do. We're going to take that number and we're going to see how close we are. We're going to take it and we're going to square it. So grab your calculator. I'm going to slide this over so it's a little bit out of the way here, and we're going to take 7.5 and we're going to square that. The squaring button is right there, and we're going to hit enter. So we get 56.25. Now it's a little bit too big. We wanted 55, it's 56.25. So if it's too big, make it smaller. All right, so let's go ahead and do that. We're going to do 7.4 and we're going to square that. Okay, so that's a little bit too small. And if it's too small, we're going to make it bigger. Now I've got a little note here. Don't forget deep recall and the insert features of your calculator. So let me show you what I mean by that. Remember, if we hit second and then enter, it's going to recall that. So we've already got 7.4. We want a number that's a little bit bigger than 7.4, but a little bit smaller than 7.5. And one way to think of that is think of this as 750 and 740. So let's put a 5 right here. Okay. And then we'll hop out on the end. 55.5. So that's a little bit too big, so we need to make it a little bit smaller. Okay, so let's go with 7.44. Whoops, what did I do there? 7.4, whoops, 44, and then we'll square that. Okay, and we could use that deep recall feature. Okay, still a little bit too big. So I could do 7.4, whoops, get that right, 7.4, let's try 4.2, and then we'll square that. Okay, now even now it's a little bit too big, but I want you to take a look here. We're doing 7.44, 7.42, and so forth. I'd like you to take a look at this last part right here. Okay, so it says we're going to continue this process until the numbers you square are extremely close to 55. They were, if the hundredths place on the numbers you're squaring are 4 or less, we're going to say, we're going to leave the tenths place alone. So remember, we had 7.44, 7.42. Well, it wouldn't make any difference on either one of those. If we were going to round down, because that's what we'd do with 4 or less, we'd call it 7.4. Okay, now if by chance the hundredths place is 5 or more, then we're going to round the tenths place up. We'd bump that up to 5. So let's say we were squaring it and it was 7.48 or something like that. Then we'd bump that up and we'd call it 7.5. But it's not, it's one of these. So our approximation is going to be 7.4. Okay, that is going to be within a tenth. Okay, all right. So we could carry this out and get more and more accurate, kind of hone in those numbers. But we just want to have an estimate that's within a tenth. Okay, so we're going to run through here and we're going to show our thinking on each one of these. So here's what we're going to do. We're going to do the same thing we did up above. We're going to pick a number or two numbers that are perfect squares that are around 29. So let's go back up on our list. Hopefully you've got these memorized. Okay, we're looking for 29. 29 would be between 25 and 36. Okay, so here's what we're going to do. I'm going to put the square root of 25 right here and the square root of 36 right here. So it's in between 5 and 6. Okay? So let's go ahead and let's try 5.5. Okay, let's see what happens there. So we'll grab the calculator. Again, I'm going to slide this out of the way here. So we're going to do 5.5 and we're going to square that. A little too big. So we'll do 5.4, square that. A little too big, but just barely. Wow. So 5.3, and we're going to square that. I bet this is too small. Let's take a look. Yeah, it is too small. So again, when you're trying to pick a number that's between the two of these, think of this as 5.40 and 5.30. Okay, so we've got 5.30 and 5.40. Those are the two that we tried. So let's try this. Let's try 5.35. So think of this as 30 and that is 40. So let's go ahead and try that. 5.35. And we'll square that. And we'll see what we've got, 28. So we need to make it a little bit bigger. Now, catch this. If we go to 3.6 and we square that. Okay. Let's see. Gosh, that's getting closer, but take a look here. The hundredths place is going to be either a 5 or a 6 or a 7. I mean, we could keep going. Let's go ahead and try 3.8 and see what happens there. Oh gosh, we're really close. Now, either way, we're going to take these numbers. Once we get to 5.36 or 5.37, all of those are going to round to 5.4. Okay? Now, as long as we say within a tenth, here's the interesting thing. So this is where you get a little bit of leeway. As long as we say within a tenth, if you narrow it down between the two of these, either one of those would be okay. This is actually rounded to the nearest tenth, so that would be okay. But 5.3 or 5.4 would be okay. I'd be okay with either one of those. That shows some good estimating skills. So let's do the same thing here with 34. So let's think about this. Gosh, it's between those two same ones right there. So this is going to be the square root of 25 and the square root of 36. Gosh, it's going to be really close to that one. So let's not guess 5.5. Let's guess like I'm going to guess 5.8. So let's try that one. So 5.8, and we're going to square that. So again, this is just, we're kind of messing around with the calculator. Getting kind of close. We need it to be a little bit bigger. So we're going to try 5.9. See what happens there. Ooh, that's a little bit too big. So it's somewhere in between there. So again, we're going to think 5.80 and 5.90. So let's try 5.85. And then once you do enough of these, you might be able to tell just by looking at this one right here. Okay, it's a little bit too big. Okay, it's 34.2 instead of 34. That means that that hundredths place is going to have to go down. So that means a really good answer would be 5.8. Now, again, I would accept either one of those. Those are both really close. They're within a tenth or so, so not too bad right there. Let's take a look at 86. Again, can you think of what that would be between? That would be between the square root of 81 and the square root of 100. Those are perfect squares that are right around there. So that would be between 9 and 10. Let's see, which one do you think it's closer to? If this is 86 and that's 81, and this is 86 and this is 100, gosh, I'd say it's a lot closer to that. So maybe we try 9.3 to start with, and let's see what we get here. I'm going to clear this off so we don't have quite the mess. 9.3 squared. 80, oh, really close, but going to be a little bit smaller. So let's try 9.2. Yeah, quite a bit smaller. So that means it's between 9.2, and I'm going to put a 0 here, and 9.3. So let's say 9.25. And again, that little 5 right there, so 920 and 930, 925 is right in between, and this should be able to tell us what it's going to be, 9.25. So again, if it's a little bit too big, we're going to have to bump it down, which means we're going to go with 9.2. If it's a little bit too small, we're going to have to bump it up, which means we'd be rounding there. So it is a little bit too small. Okay, not quite. So let's do 9.26, and we'll square that. Yeah, that's getting closer. So either one of those, 9.25 or 9.26, that's going to round to 9.2. But again, either one, 9.20 or 9.30, that would be just fine. Now, if we really wanted to challenge ourselves, what would the square root of 139 be within 100th? So if you want to be within 100th of the correct answer, we've got to go even further. Now, if you're interested in seeing how that works, tune in. If not, this is for the most part how the assignment's going to look, but I am going to run through and do this example really quickly. So I'm going to keep in mind that this is between the square root of 121 and the square root of 144. So it's got to be somewhere between 11 and 12. And I'm going to notice that, gosh, this is in the 30s, just barely short of the 40s. I think it's a little bit closer to that one. So I'm going to say like 11.8, and let's see how close we can get here. So we're going to I'm going to slide this over so we can see the original problem here. So this is going to be 11.8, and we're going to square that. 139, a little bit too big. So we're going to make this 11.7, and we'll square that. Okay. Gosh, that's a lot smaller, so it's got to be in between there. So we're going to say 11.75. We'll square that. Again, we're using this kind of inverse relationship here, so it's got to be a little bit bigger than that. So we'll do 11.78. Square that. Ooh, let's see, 11.79. Square that. Okay, that's a little bit big. So that means it's in between 11.78 and 11.79. So I'm going to write those down. 11.78 and 11.790. So let's think, if it's in between the two of those, it's in between 11,780 and 11,790. So let's try 11,785. And let's see. Whoops, I didn't get the decimal in there. So 11.785. And we'll square that. Let's see what we've got here. So this is a little bit too small. So this should tell us we're going to continue making that 5 bigger, which means to the nearest hundredths place. So let's try this one, 11.786, and we'll square that. Okay, getting even closer. So either way, this is going to be a 5 or a 6 or maybe even a 7. We're going to bump that up to a 9. So we're going to bump that up to 11.79. Now, just for the heck of it, for those that tuned into this, I'm going to hit the square root of 139, and we're just going to check this. We're going to confirm our answer here. So 11.789, and if you rounded to the nearest hundredths place, the 9 would bump that up to, that 8 up to a 9. So it's either 7.8 or 7.9. We do bump that up to a 9. So we got that right. Okay, all right, that's the process. I know it seems kind of weird, but that whole process of approximating is a really good skill to have.